x squared, 6x, and 5x plus 12 are three successive terms of an arithmetic progression. Find the possible values of x. Now, remember, as usual, whether I tell you or not, you should pause the video, write the question down, and make an attempt at answering it. Alright? So, go ahead and do that for this question. Okay, so you're finished. What did you get for it? Let's work this thing out. Here, remember, with an arithmetic progression, the second term minus the first term would be equal to the third term minus the second term, and so on and so forth. This gives you the common difference, D. So any term minus the term immediately before it is equal to the common difference. Here, you see these are three successive terms. So these are three terms in a row. No term was skipped. Now, if this, the x squared, is one term, the 6x is the next term. So therefore, this next term, 6x, minus the term immediately before it, that would minus x squared, must be equal to, now the 5x plus 12 is the term immediately following 6x. So 6x is the term immediately before 5x plus 12. So let's subtract them. So the 5x plus 12 minus the term immediately before it, which is 6x. So these two things must be equal. Alright? So you see that? So here, from now, you can see that there is x, number x, alright? There is number, and there is x squared. So it seems as if when you simplify this, you're going to get a quadratic equation to work with. So let's go ahead and simplify and see what's going to happen. Let us transfer everything over to the left hand side and make them all equal to 0. So what you have is 6x minus x squared. Subtract 5x from both sides, you get minus 5x on the left. It subtracts itself on the right. Subtract 12 from both sides, you get minus 12 on the left. 12 minus 12 on the right is 0. Then with the minus 6x, you have to add 6x to get rid of it on the right. So you must say plus 6x on the left. It negative 6x plus itself on the right, that's gone. There's nothing left on the right hand side, so that's all equal to 0. Alright? So here, let's put the things, all these things together. The negative x squared. Then you have x's. So you have plus 6x minus 5x plus 6. And numbers, minus 12 equals 0. So you have negative x squared. 6x minus 5x is 1x. I left off the x from this 6. My. So 6x minus 5x is 1x. 1x plus 6x is 7x. So plus 7x minus 12 equals 0. Okay. Now you could very well work with this as a quadratic equation, but in order to reduce confusion, let's make the x squared part positive. Let us multiply both sides of this equation by -1. All the negatives will become positives, all the positives will become negative, but the numbers will remain the same in magnitude. So you're going to have positive x squared minus 7x plus 12 equals 0. Okay, good. Now, I think you would be able to factorize this, right? Using -4 and -3. Once you've been practicing your factorization regularly, you can see that it can be factorized. But let us practice our completing the square. Completing the square is a nice method to use. It's a basic method and it can be used on any quadratic equation. In fact, the quadratic formula comes from completing the square of ax squared plus bx plus c. So let us practice our completing the square here. So remember, completing the square, generally you have a plus h squared is equal to a squared plus 2hx plus h squared. This is a complete square, right? Perfect square. Now you have, in this case, x squared plus -7x plus 12 equals 0. Now here you have, oh, why did I put a here? It's x. That I should have x plus h squared is x squared plus 2hx plus h squared. Right. My mistake there. Now, we want to write the left hand side as x plus something squared. But that something is h. Now, looking at this, looking at the pattern, we have 2h times x. And we have -7 times x. What that means is 2h is equal to -7. So what is h? H is equal to -7 over 2. That is h. Alright? So now we add the h squared. This h squared, we're going to add it here. And this will give you h squared, which is -7 over 2 squared. Alright? So this is plus -7 over 2 squared. We don't want to square it out and say 49 over 4. Right? We don't want to lose certain values like the negative sign and seeing exactly the h. We want to see what was that squared. So we maintain the -7 over 2 and write it as -7 over 2 squared. Okay, now look at this. This x squared plus the 2hx, which is -7 x, and we maintain the fraction. Note, we don't write it as -3.5, we maintain the fraction -7 over 2. That's 2h, and then when we come to the h part, that's when we have h is -7 over 2. So the h squared is -7 over 2 squared. Alright? So we have the x squared plus the 2hx, which is -7x, so 2h is -7, plus h squared. H is -7 over 2. We maintain the fraction, -7 over 2, and we don't square it out as usual and lose the negative sign. We want to see the h as it is exactly, so we write -7 over 2 squared. Now, here, we're going to transfer from this form to this form. This is x plus what squared? It's 8 squared, and h is negative 7 over 2. So it's negative 7 over 2 all squared. Alright? I guarantee you, when you multiply out all of this, it's going to be x minus 7 over 2. So x minus 7 over 2 times x minus 7 over 2. It will give you the x squared plus negative 7 over 2x plus, now I mean the negative 7x plus the negative 7 over 2 squared. It will give you that. Alright, now we need to fix this thing up. We just added the negative 7 over 2 squared. It was not there before. It is something new, right? It was not here. We had the x squared, we have the negative 7x, and we had the 12, but this was not there before. So you need to compensate so that you put something else there to wipe this out, but effectively wipe this out, whatever effect this has. You're going to erase that effect. You can do two things. Since you added this on the left hand side, you can add it on the right hand side. Or since you add it on the left, you can subtract it back on the left as well. Any one of them you want to do. Now we added it on the left. Let's just add it back on the right. It's negative 7 over 2 squared. Alright? Now, this was somewhat rough work, so let's erase it. We don't want to mix it up with the regular work we're doing. And just to note, factorization would have been finished already, but I just wanted to practice. I want you to practice the completing the square. Alright. Now, you see, this part is this part, So we put back the plus 12 equal negative 7 over 2 squared. Oh, negative 7 over 2 squared. Now, let's keep this as it is and transfer the 12. Subtract 12 from both sides. We have x plus, well, we don't need to keep writing it as plus negative 7 over 2 squared. We can now just write it as x minus 7 over 2 squared. Alright? Equals negative 7 over 2 squared minus 12. What would this work out to be? We can now square it out because we want to find x. Negative 7 squared is 49 over 2 2's 4 minus 12 over 1. Using common denominators, this can be written as 49 over 4 minus, multiply the 1 by 4, you get 4, multiply the 12 by 4, you get 48. So this is 49 quarters minus 48 quarters, which would give you, well, this would be 1 quarter. 49 of anything minus, you take away 48 of them, you're left with 1. So you have x minus 7 over 2 squared is equal to a quarter. Let us now square root to get rid of the square. This to square root both sides, so you have x minus 7 over 2 is equal to the square root of a quarter. But remember, you always have two square roots, so one is positive, one is negative. The square root of a quarter is half, so it's positive and negative half. So now x minus 7 halves is equal to positive and negative 1 half. Add 7 over 2, 7 halves to both sides. So you have x is equal to, going to have 7 over 2 plus or minus 1 over 2. So So you have two possible values for x. X is equal to 7 over 2 plus half, and x is equal to 7 over 2 minus half. So in this case, x is equal to 7 half plus 1 half is 8 halves. 8 halves is 8 over 2, which is 4. And also x is equal to 7 minus 1 is 6. 6 over 2 is 3. So x is 4 or 3. Okay. So quick review. We have these three terms that are successive terms of an AP. Find the possible values of x. We say the second minus the first term would be equal to the third minus the second term. That would be the common difference d. When we put it together and simplify, you get a quadratic equation. And then you solve that quadratic equation. You could have used a formula or factorization. It wouldn't really be reasonable to use any graph, even though that's one method you can use to solve quadratic. But you could have quickly, if you remember the formula, you could use it or use factorization, but I just chose to use completing the square to review our completing the square method, and you get x equal 4, x equal 3.